earlier we talked about the 4 techniques that we can use to find the limit of indeterminate forms. So for this particular example, we're going to exercise the technique of L'Hopital's rule. So like I already said, the 4 techniques that we can use are algebraic manipulation or factoring, change of variables, the squeeze theorem, and L'Hopital's rule. So for now, we're going to look at a function and we're going to see that it gives an indeterminate form, and then we're going to use L'Hopital's rule to solve it. So something about L'Hopital's rule is that when we are going to apply L'Hopital's rule to an indeterminate formed function, we need to make sure of 2 things. That is, we need to make sure that the function that we're working on is in fact in an indeterminate form, and the second thing that we need to make sure is we need to make sure that the function that we are working with is differentiable at the given limit. So to understand that better, we're going to look at a function here. So for example, if we have the function f of x equals to ln of x divided by x minus 1, and then we're asked to find the limit when x tends to 1 of this given function here. So like I said, we need to make sure of 2 things. So the first thing is we need to make sure that this function is indeed at an indeterminate form to begin with. So at the given limit, what we get is ln of 1 in the numerator and 1 minus 1 in the denominator. So from here you can see that in the numerator we get a 0 because ln of 1 is 0, and also we get a 0 in the denominator. So this in fact is an indeterminate form. And the next thing that we need to make sure is that our given function is differentiable at the given limit. So you can see from here that at x equals to 1, our function is definitely differentiable. So we can just go ahead and use the L'Hopital's rule now. So what the L'Hopital's rule is that we find the differentiation, we find the derivative of the numerator and the denominator separately. So for this case, we have the numerator to be, for example, if we name it as g of x, the numerator, we have it as ln of x. Now what we have to do is we need to derive or find the differentiation of the numerator separately. So we get g prime of x, the first derivative, as 1 over x. Now moving on to the denominator, we also need to find its derivative separately. So we denote it as h of x, and we have x minus 1, and deriving it once gives us 1. Now we can just go ahead and plug in these values. So what we will have is f prime of x, and it will be 1 over x divided by 1, and we're taking the limit when x tends to 1. So you can see from here that what we get is basically limit x tends to 1 over x, and imposing the limit just gives us positive 1. So now you see that we avoided the indeterminate form and we used L'Hopital's rule, where we took the differentiation of the numerator and denominator separately, and we found the answer to be 1.